Okay, so how many millimoles of iron 3 oxide? So we should be writing the formula for iron 3 oxide. That is Fe3 plus combining with oxide, which is 2 minus, so we have Fe2O3. Can be made starting with 7.43 grams of iron atoms. So we are starting with Fe atoms. Hang on. How many millimoles? Now I'm going to do a little math before I actually do this. We are starting with 7.43 grams of iron, and we want to finish eventually with millimoles of Fe2O3. Now, what can we convert grams into? Grams can be converted into moles. So that grams of Fe can convert to moles of what? It can only convert to moles of Fe. Now I'm actually going to work both forwards and backwards. Okay? If I want to end up with millimoles of Fe2O3, what would I have to get to before that? Millimoles, I would need to have moles of Fe2O3. So I'm trying to connect the front with the end. Do we know a conversion factor that converts between moles and moles? Particle ratio. Sorry, mole ratio. And the mole ratio is the same as the particle ratio. So this is going to be a 3-step problem. You could do this in more steps. I could see someone solving this in 5 steps. You go from moles of iron to atoms of iron to number of Fe2O3s to moles of Fe2O3 to millimoles of Fe2O3. But using the mole ratio makes this much more efficient. Okay? So we're going to start with 7.43 grams of iron times, what do we want to cancel?
Grams.
Grams of iron, and we need to find the
Molar mass.
moles of iron, so we need to find the molar mass. Molar mass of iron is 55.8. Okay, so calculator. Not that we're ready for that yet. So my grams have canceled out, and now I have moles of iron. For moles of iron, I want to go to moles of Fe2O3. So I can cancel moles of Fe2O3. Nope, that's not what I want to cancel. What do I want to cancel? Moles of iron, okay, because that's what I have on the top. So whatever you have on the top, it'll go on the bottom to cancel it, unless you're canceling something on the bottom, in which case it would go on the top. Okay. And we want to find moles of Fe2O3, moles of Fe2O3. What is the ratio between iron and Fe2O3? 1 mole of Fe2O3 equals 2 moles of Fe. That's because of this little 2 down here, yes? Fe2O3. And then millimoles, we want to cancel the moles and find the millimoles. Now, Milli is 10 to the negative 3. And remember, the one goes with the if you're changing prefixes, though, the one goes with the prefix, the one goes with the prefix, the one goes with the prefix, unless it is molar. Okay, never mind. The one goes with the mole, but if you're using 10 to the negative 3, you're going to go that way. You could also use this conversion factor, 1,000 millimoles is equal to 1 mole if you prefer that. Yes? I don't care what format you use, or you could use 10 to the 3 millimoles is equal to 1 mole, whichever one makes the most sense to you. We churn that through our calculator, 7.43 divided by 55.8, divided by 2, divided by 1, E3 negative equals 66.577 rounds to, we need 3 sig figs, 66.6. Oh, it's the question of the beast. Wow. Millimoles. There we go. We good with that? Any other questions? Does everyone know how to find the molar mass of a molecule? Yeah, so if I was like the molar mass of a molecule, oh no, the mass of a molecule is 2.1 times 10 to the negative 22 grams. What is the molar mass? Could you guys do that? Please let me know if you can't read any of that. That's a bunch of chicken scratches there is what that is. The mass of a molecule is 2.1 times 10 to the negative 22 grams. What is the molar mass? Try it. And then if you get that one, you can try You can do it in one line like that, or you can say molar mass, capital M, molar mass is equal to grams over moles, and that is equal to 2.1 times 10 to the negative 22 grams over, and we don't know what the moles are, and you can say, well, what are the moles? And this is a two-line way of doing it. What are the moles? Well, I have one molecule, right? Because it says a molecule. That means one molecule. One molecule times 1 mole per 6.02 times 10 to the 23 molecules. (1.66 times 10 to the negative 24 moles. Chuck that in there. 1.66 times 10 to the negative 24 moles equals 130 grams per mole. Is good? If you got that one, find the density of fluorine gas at STP. Yes. Yes, for sure. Help yourself. Remember, you can go from density to molar mass, or you can go from molar mass to density. Because it's a gas. You can't do that with other things, but you can do it because it's a gas. Yeah. To do this one, you could say I know that the molar mass is 38 grams per mole, and you could say that means 38 grams per 1 mole. So you could say I have 1 mole. Yes? So I could say 1 mole is how many liters? Yeah? And this is of a gas. So I could say I have 1 mole of gas. There is 22.4 liters per 1 mole. So that gives me 22.4 liters. And then I could say, I know I have 38 grams. And I know that my 1 mole is 22.4 liters. So my density in grams per liter is going to be 1.70 grams per liter. Yeah? Are we ready to do dilution? Yeah, for sure. Well, if we're not ready, we're going to do it anyway. Let's see what we got here. 5.7a. There we go. Dilution. So I'm going to get a what you call it, beaker here. And we're going to put some water in it so you can really visualize this. It's in 2D up there, but let's have it in 3D. Okay, so each of these represents 1 mole. Okay? Each of these little corks represents 1 mole. And we're going to pretend that this is 1 liter because I don't want to pour that much water. Okay, are we good with that? So, well, actually, we'll pretend it's 1 liter once I've put these in, okay? So that's 1 liter, and it contains 2 moles. So this is, what's the concentration of this solution? 2 moles in 1 liter is 2 moles per liter. Now, what if I add 1 more liter of water? I have diluted that, yes? Now I have 2 moles in 2 liters, which is 1 mole per liter. But did the number of moles change? The key idea of dilution is that the number of moles before the dilution and after the dilution stays the same, okay? So we've got a little picture of that here, and you can see it's written up there. So we have 2.0 liters of a 9 molar solution. Now, do you guys remember what the word of means mathematically? No? What does per mean? Per means divide. Of means multiply. Times. Okay? So if you don't know what else to do with this problem, if this is a dilution problem, if you have an of in there, you can take your 2 and you can multiply by your 9 molar. Yes? Okay, now why is that going to work for us? Remember, when you're working with molarity, you're not going to leave 9.0 molar as 9.0 m. You're going to rewrite it as 9.0 what? Moles over liters. And if we want to find the number of moles, because in a dilution problem, you're always trying to find the number of moles because the moles before equals the moles after, okay? So if we want to find the moles of NaCl, we're starting with 2 liters of 9.0 moles per liter. And what happens with our liters there? They cancel out, and we end up with 18 moles of NaCl. Now, our new concentration, our final volume, is 6 liters. So our new concentration is equal to 18 moles divided by 6 liters. Find the new concentration of NaCl. So our final volume is 6 liters, because remember, molarity. Is molarity a conversion if we're trying to find molarity? Molarity is a division calculation. We have 18 moles per 6 liters, yes? Per means divided by. So we have 18 moles per 6 liters. That equals 3 moles per liter, which we can then rewrite as 3 molar. Is good? Okay. So that's how you take an initial quantity and you dilute it and you find the new concentration, the new diluted concentration. Let's try another one. Actually, there is no other one here, but let's try one here. Let's try number 4 together. Do you guys want to try number 4 on your own first? No, you want to do it with me? Okay. So at the start, what do we have? We have 20 milliliters of 0.75, and I'm going to rewrite molar as moles per liter, HBr. Oh, I don't want this one. Is diluted. Let's just say is diluted with, is diluted. Can we cross that out? With 70 mils of water. What is the molar concentration in the resulting solution? So at the start, we have that. At the end, what is our volume at the end? What is our final volume? What is our final volume? We have 20 milliliters and it's diluted with 70 milliliters of water. Final volume is 90. So you have to watch what the question says. The question might say the final volume, or it might say we added this much water and you'll need to calculate the final volume. Does that make sense? So either you'll be given the final volume or you'll have to add the two together to get the final volume if it says this much water was added. So at the end, we have 70 milliliters. And in the dilution problem, what is the first thing you want to find? You want to find moles. Can you find moles here? You have a volume and a molarity. What should we do with our 20 milliliters? We should convert it. How many places do you need to move your decimal place? 1, 2, 3. So that's going to be 0. Okay. Sure. 0.020 liters. Now I want to show you a mistake that many students make at this point. They get all excited and they say, I need to find my concentration. What is concentration? Concentration is what over what? Everybody, I know it's been a long weekend. Let's wake up again. Concentration is what over what? Concentration is moles over liters. And people will say, oh, I got my moles. Hold on, because this is what people do wrong. Don't copy it down. They say, oh, I'm going to divide that by my final volume. Whoops. Should that say 70? That should say 90. I don't know what was wrong with me there. Okay. And they'll put 0.090 liters. Tell me what is wrong with that. Is the left-hand side of the equation equal to the right-hand side of the equation? Is 0.015 equal to 0.167? No. So you can't just throw something in the denominator on the other side if you want it to stay equal. Yes? If you want to just throw that underneath, there are a couple of options. You could, if you want to do the part that's in blue, you could do that to the other side as well, 0.090 liters. You could do that and now it still stays equal. Does that make sense? Or if you don't want to do that, the other way to do it, and this is actually probably the preferred way, is to say, now that I have found the moles, I will find the concentration of HBr. And I'll let you know that if you're finding concentration tomorrow and you don't write concentration HBr equals, you will lose a half a mark. This is worth 0.5. Yes? And that's equal to moles over, which is equal to 0.015 moles divided by 0.0900 liters. And we get 0.17 moles per liter or molar. Yes? I started with 20 milliliters and I added 70 milliliters. Is diluted with 70 milliliters. So I started with 20 and I added another 70 milliliters of water. Yeah? Are we good with that? Okay. Let us do 5.7b. Okay. And there's actually a lot of stuff in here that I'm not going to go over today. I'm just going to take you through it really quickly. Often our lab storeroom, we have, I'll look at an example for you. Okay, I have here some 0.5 molar copper 2 chloride. And here I have some 0.2 molar copper 2 chloride. Which one is more concentrated? 0.5 or 0.2? 0.5. So what did I have to do with this one? I had to take some of this and add water. So the question is, like, let's say I wanted 1 liter of the more dilute stuff. Actually, let's go off script here for a moment.
I used to watch them.
Yeah. So if you are given 0.5 molar CuCl2, and you want to make 1 liter of 0.2 molar CuCl2, what volume of the 0.5 molar solution do you need? So we know the molarity of the 0.5 molar solution, yes? Do we know the volume of the 0.5 molar solution? Nope. Because that says what volume do we need? Okay, what volume? We know that we want 1 liter of 0.2 molar CuCl2. Oh, look what we have here. What word do I see? I see the word of. And when I'm doing a dilution problem, what is the first thing I'm trying to find? Dilution, step 1. Find the, what's the whole unit about? Moles. So step number 1 of a dilution is find the moles, because what happens? The moles before is the same as the moles after. So you're going to need moles to solve the problem. Find the moles. So it doesn't matter whether you're diluting one way or diluting the other way. It doesn't matter. Okay, so we're going to find the moles. Okay, and to find the moles, we have 2 pieces of information here. We have 1 liter and we have 0.2 moles over liters. Can we find the moles? Moles of CuCl2 is equal to 1 liter times what? What do we need on the bottom? We need liters on the bottom. What do we need on the top? Moles. And what is the concentration of the 1 liter? 0.2. 0.2 moles per 1 liter. Yes, you with me? Okay, and if you don't know what else to do, you can be like, oh, look, 1 liter times 0.2 moles per liter, right? Like in a dilution problem, whenever you see blah, blah, blah of blah, 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 just do that multiplication and it will give you moles. Yes? Okay, so we have 0.2 moles. Now we need to find a volume, which is, what do we measure volume in?
Liters.
Volume is measured in liters. So we don't know how many liters of 0.5 molar is going to give me 0.2 moles, because I need 0.2 moles, right? My moles after, moles before. What volume of 0.5 molar? And remember, 0.5 molar is 0.5 moles per liter. Where do the moles go? I want to find the liters. I'm starting with moles. Where do the moles go? On the bottom? Where do the liters go? On the top? And I have 0.5 moles per liter. So 0.5 moles per 1 liter. So 0.2 divided by 0.5 is 0.4 liters. So I need 0.4 liters or 400 milliliters of this stuff, and then I dilute it to 1 liter and I get 1 liter of this stuff. That kind of makes sense? Okay. So we're just going to bop on over here and I'll show you how you would do that. How you would do that is you would take your stock solution. The stock solution is the more concentrated solution. This is on page 103. And you will measure it out with a volumetric pipette. Or if the volume is large, what could you use to measure out? Like, let's say we had this question we just did, and I wanted 400 milliliters. Do you think I have a 400 milliliter volumetric pipette? Like 400 milliliters is like this much. What could I use? I could use, beakers are terrible at measuring. Something that's better at measuring. I could use a graduated cylinder. Yeah? And then what you'll do is you will take your stock solution and it goes into, what do we call this piece of equipment here? That is a volumetric what? Flask. So you put your stock solution into the volumetric flask. And then what would you add? What would you add to dilute it?
Water.
Add water. And where would you add it up to? You would add it up to the line. And then you would cork it, shake it. Is good? Okay. So tell me, here are the math steps for dilution. Type 2. What volume of stock? What is the first thing you need to figure out in any kind of dilution calculation?
The moles.
Find the moles of solute you need in the final solution. And then you'll figure out what volume of the final solution contains that many moles. We good? This is not on tomorrow's quiz, by the way. Dilutions are not on tomorrow's quiz. So if we want to make 2 liters of 2 molar, and each of these equals 1 mole. And we want to dilute a stock solution of 8 molar. How much of the stock solution do we need? So we want 2 liters of 2 molar. I want 2 liters of 2 molar. How many of the black dots do I need to have 2 liters of 2 molar? I want this to be 2 moles per liter. I need 4, right? I need 1, 2, 3, 4. Okay, that is 4 moles over 2 liters is 2 moles per liter. Now my stock solution is 8 moles per liter. So if this is 1 liter here, how many moles do I need in this 1 liter? I want 8 moles per liter. This is my 8 mole per liter. This one's easy. I need 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is my original stock solution. How much of the stock solution do I need to get? How many moles do I need here? I need how many moles? I need 4 moles. Yeah? I need 4 moles. How much of the stock solution do I need to get 4 moles? This volume here, this whole volume here is 1 liter. I need a half a liter, yes? So that's what we're doing is we're going to take this half liter, we're going to pop it in here, and then we're going to add water to the 2 liter mark. Is that kind of making sense? Yeah? Now, if we wanted to show this using conversion factors, we're going to find the moles. Woo, that was exciting. Find the moles of solute needed. Well, we know we want 2 liters of 2 mole per liter. Oh, what do? We want 2 liters of 2 mole per liter. How would we write that mathematically? You guys are killing me. Yes? I need to have 4 moles. Now the question says what volume of the stock solution? And remember, you are told the concentration of the stock solution. And that is 8 moles per liter. So we need to find the volume of this stock solution. So we want to find the number of liters that contains 4 moles. What needs to cancel? Everybody, what needs to cancel?
Moles.
Moles. Excellent, thank you. And what needs to go on the top? Liters. And do I want to use my 2 moles per liter or my 4 moles or my 8 moles per liter? 8 moles per liter. So 8 moles per liter. And that gives us 4 over 8 is 0.5 liters. Is good? Okay. So we are not going to worry about the rest of this for now. All right? What time we have left in the class, you can work on review for tomorrow's quiz. Your homework is to review for tomorrow's quiz. I'll give you some dilution homework after the quiz tomorrow. Okay? If you're already ready for tomorrow's quiz, you can start on the dilution stuff. And I think I have here Chem 11. Oh my gosh, it's dead.
What?
Oh, there we go. Homework. Now this is on Teams, but just in case you're not a Teams fan, I'll let you take a picture of this up here. Okay, so if you want extra practice, there's extra practice. Yeah. Your unit test is going to be next week. How about Tuesday? Next Tuesday. Or is Tuesday too soon? I can do Tuesday or Wednesday. I don't care.
Wednesday.
Wednesday, next Wednesday?
Yes.
Okay.
Wednesday.
Unit test next Wednesday. Although you know what, you guys would study better on the weekend if I said it was Tuesday.
No, Wednesday.
I don't care.
But how would that, Wednesday is definitely.
Take me your time. This one's 5 days.
That's not the option.
I don't
Yes.
want it cold still.
I'll taste it.
Okay. Right. Holy crap. Yes. Something.
I'm being confused for like
Okay.
all of this because
Yeah.
that usually like leaders are running now.
Yeah, and that's because you don't want liters, you don't want grams per liter, you want grams per mole. Molar mass is grams per mole. So you want to cancel the liters and find the moles. And you want moles to be on the bottom because it's per mole.
Mm.
Yeah?
So are those like the right stuff?
Mm-hmm.
Can I
Absolutely.
just do it with you to make
Yeah.
sure? So,
For sure. I'm just gonna turn this off so it doesn't blind everybody as they walk past, and you included. Okay.
so I don't know what's gonna be if it was, but
No, that's good. Oh, there we go, 3 it.
this is per 1 unit, right?
Mm-hmm.
And then for this, we're going to moles,
Mm-hmm.
70 grams per mole,
Mm-hmm.
and then liters go to
Well, where do you want liters to go to cancel out?
there.
Yes.
So do I have to put liters up there and cancel?
Yes, that's why you put it up there.
Or, wait, then why would I put? Oh, it's because the grams are on the top.
Yes. So molar mass, if you want to, you can say grams over moles here to like show yourself where you're going. Okay.
So then. I have to do another conversion factor.
Well, let's see. What do your units do? Cancel out what you can cancel.
Liters?
Yeah. So, do you now have grams per mole?
Yes.
Oh,
And then. Oh.
and then what goes in here? Anytime you see gas at STP, you're going to use.
22.4.
Yep.
So I put that with moles?
The one goes with the,
No.
unless it is molarity. One goes with the mole, unless it is molarity.
So this would always go with like a
The
liter.
Yeah.
Okay.
Yeah.
And then.
Cool. Whatever it is. Yes.
So is that like all? If I'm starting with molar mass, it's always
Always going to be
to
like
this.
that. Mm-hmm.
Okay.
Do you want to try density of xenon?
Do I need my PR?
Us. Oh, I think you three other table here. Xenon's done it. Anyone got a question? Oh, strong. Okay.
Because it's a gas, it's not in.
It's still grams.
Is it?
Now, yeah. So your molar mass is 131.3 what? What are the units of that?
It's like grams per mole.
Mhm. Now, if you want to find density, what is density measured in?
Volume? No. I don't know.
Mass over density is mass over volume. So density, mass over volume is equal to, and we're going to start with this because we've got mass. Yes? 139.4 grams. Moles. So we have grams. Yay. We don't want to have moles. We want to have volume. So what do we need to cancel? Mm-hmm.
I don't put the grams down there, do I?
Do you want to cancel grams?
No.
No, you want to keep grams, right? So leave the grams alone because you want grams over volume.
Volume here.
Mm-hmm.
And then.
Now, what is the unit of volume? If I said, what's my volume? You would measure it in
No.
or
Liters.
liters. Go with liters because it's a gas, right?
Yeah. So.
So instead of volume, you're going to write the unit, which is liters. There is volume. Because you don't really want the quantity there, you want the unit, yeah?
I don't know.
Yes, you do. It's a gas at STP.
But it's not, is it 22 point?
Yes. Every time it's a gas at STP, it's always 22.4 liters per mole. Always.
Always?
Every single gas.
Oh.
Every single gas.
Oh.
Yeah.
Alright, I'm just gonna have to remember that one.
Yeah. Anyone got a question? Guys, you're too competent. You know everything already. You know everything already? You know everything already? Study some more? Yeah.
Yeah.
Yeah. And remember, if tomorrow, if you're like, oh my gosh, I don't know what I'm going to do, you can use your yellow sheet for the low, low price of 10%. Now, if you're like, oh my God, 10%, that sounds like a lot. Have we done more than 10 quizzes so far this year? Yes. How much are quizzes worth out of your grade? 10%. So if there are 10 quizzes, let's just assume there's 10, it's actually more than that, so each quiz is, then each quiz is worth what percent? 1%. And what is 10% of 1%? 0.1. Now, if you have more than 10 quizzes, it's less than 0.1%. So if you really feel like tomorrow you're going to die without the thing, then take the 10% and off you go. Okay? Or you can start without, and then you can be like, oh, you can decide later on. You can be like, oh, I have not studied enough. But don't not study enough. Go home and study your arse off tonight. Okay?